Somebody? Can you hear me? Can you hear me?
Yes.
Okay, thank you.
Professor Gu, just one short question. You told us that the first quiz is going to be next week, is that correct?
I believe so. You have to confirm with your TA.
Okay.
All right, so before we start, okay, so
The chances said that they don't say anything to your parents about that.
all right. Any question before we start?
Don't say a word to them.
And then you have all got my email and island announcement regarding the first midterm, right?
Yes.
Say yes, please. Say yes, please.
Yes.
All right, so
like just learning or something. I forget.
Can you please mute
Right.
yourself, Rex?
so let's continue our discussion about the chapter 10. Okay. So this is what we have done so far. So again, we are dealing with the income expenditure model under the assumption that the prices are fixed. Okay, prices are fixed. And then, now we are dealing with the consideration of government. Okay, so now government is in our analysis. So in the last two lectures, we have been dealing with this situation where the aggregate demand in the economy, by definition, is equal to C plus I plus G. Okay. And then, once we plug in the expression of consumption, investment, and government spending, we end up with, what is going on the right-hand side. The aggregate demand for the economy is equal to C bar, autonomous consumption, plus I bar, autonomous investment, plus G bar, autonomous government spending, plus little c, which is the MPC out of disposable income, times the transfer payment. And then, C times 1 minus T here is the marginal propensity to consume out of total income. All right. So we combine these four terms all together, and we call that total autonomous spending, total autonomous spending, or total autonomous expenditures. So first equation of our income expenditure model can be rewritten in the form of equation number 1. Aggregate demand is equal to A bar plus little c times 1 minus T times 1. In a diagram, you have AD on the vertical axis, Y on the horizontal axis. AD on the vertical axis, Y on the horizontal axis will give us a straight line with a positive intersect, and the slope, which is the marginal propensity to consume out of total income, give us a straight line flatter than the 45-degree line. And then the second equation, as before, it says, in the equilibrium of the macroeconomy, aggregate demand equal to aggregate supply. Aggregate demand equal to the output or the income for the economy as a whole. So you have done this, multiple times by now. All you need to do is plug this y from the right-hand side of the second equation to the left-hand side of the first equation, and then you end up with this mathematical expression for the equilibrium output of this macroeconomy when there's a government. Yes? Yes, please. Mm-hmm. Yeah? Okay. And then, once we have equation 1 in a diagram, we can also plot equation number 2. Okay? Equation number 2 is nothing but aggregate demand equal to output, aggregate demand equal to output. So it's going to be represented by a 45-degree line. Okay, so this is our 45-degree line. Okay. So in economics, you know that whenever you deal with a diagram with two curves, with two lines, the next point that we're going to focus on is going to be the what? The intersection. All right. So the intersection gives us the equivalent output, and then you can read out the white star here, which is exactly this white star up here. Okay. So these are the corresponding expression in terms of the equivalent output in the equation, in a diagram, in the equation, in a diagram. Everybody? Say yes, please.
Yes.
Make sense? Yeah? Okay. And then on Wednesday, we talk about, now in this case, what happened to the equivalent output? What happened to the equivalent output? Whenever we want to talk about the, government's physical policy. Okay? Government's physical policy. Referring to change in government spending, change in transfer payment, and change in what? The tax rate. Okay? And the bottom line here is that at the end, either of the three policy changes will lead to what? Changes in the what? Equivalent output. This is the business cycle fluctuation. All right. This is the business cycle fluctuation. So the first case we discussed, which we began on Wednesday, has to do with what? Changes in government spending, changes in government spending, changes in government spending. And then one thing that we emphasize on Wednesday is that whenever you have a change in government spending goes up or government spending goes down, either way, you're going to result in a what? A one-to-one change, the same amount of a change, same amount of change in the what? Total autonomous spending. Change in A bar will be equal to change in G bar. They will be equalized. They are the same. They are the same magnitude. They are the same size. They are the same amount. Okay? And then, we derive, the impact of change in government spending on the economy's equivalent output in terms of the what? The government spending multiplier. This is the expression for the government spending multiplier. Government spending multiplier. All right. So we're going to put this information onto this diagram. Okay, onto this diagram. Okay. So now let me ask you this. Suppose I have an increase. I have an increase in government spending. Okay. I have an increase in government spending. Okay. We just have 1 trillion dollars, okay, on infrastructure. Okay. So infrastructure spending going up in our model corresponds to increase in government spending. So one thing very important that I hope you can learn from this class is how to apply. Okay, how to apply what do you learn in the classroom? Okay, theory, equation, diagram to the real world. Okay, the knowledge you accumulate in this class hopefully will give you a framework in your head to help you what's going on in the real world. So what is going on right now in the U.S. economy is that there's an increase in government spending, particularly on infrastructure. Let's see what happens to the economy's output, okay, when we are dealing with the income expenditure model. So question for you. When there's an increase in government spending, does that affect equation 1 or equation 2? What do you think?
Does it affect both?
No. Equation 2 will not change because equation 2 is the equivalent condition, which is always represented by the 45-degree line. So aggregate the government spending is part of the what? Government spending is part of the
Aggregate demand.
very good. So therefore, change in government spending will affect what? Equation number 1. Say yes.
Yes.
Good. And then next is equation number 1 a straight line?
Yes.
Good. A straight line has two components. One is the intersect, A bar. The other one is the slope, C times 1 minus T. So question for you. When you have an increase in government spending, will this affect the intersect or the slope?
Intersect?
Very good. Intersect. You say, oh, Professor, actually, you already told us the answer earlier because change in government spending will affect what? Total autonomous spending by the same amount, correct? Say yes. Good.
Yes.
So therefore, when there's an increase in government spending, A bar will go up. A bar will go up by exactly the same amount. Say yes. Hello?
Yes.
Hello? Good. All right. So now, you just told me, huh? Not the other way around, huh? You're teaching me, you're telling me that when there's an increase in government spending, that will affect total autonomous spending. Total autonomous spending is the intersect of equation number 1, correct? Yeah? Hello?
Yes.
Yes. So when there is an increase in the intersect, when there's an increase in total autonomous spending, what happened to my equation? What happened to my equation 1? What happened to the straight line? Are you going to see a parallel shift or are you going to see a rotation? The intersect goes up, right? Intersect goes up, correct? Say yes. The slope doesn't change, right? Yeah?
Yes.
Okay, good. So therefore, you should expect to see a parallel shift. You should see a parallel shift on the economy's aggregate demand. So this will give us our A bar prime. Say yes. Hello? Yes. So this will give us AD prime. So the intersection of the new aggregate demand because of the higher government spending will give us a new equilibrium E prime. And then this will give us the new equilibrium output Y prime. Agree?
Yes.
Yeah?
Yes.
Look at the diagram, huh? All right. So now, therefore, the difference between change in Y star and change in Y star and Y prime, this differences. Y prime minus Y star is our changes in equilibrium output. Say yes.
Yes.
Hello? Say yes.
Yes.
At the same time, on the vertical axis, the difference between A bar prime and A bar, which is denoted as change in A bar, is exactly equal to change in G bar. Yes? Hello?
Yes.
Okay? So, the concept of government spending multiplier is nothing but change in the equilibrium output on top, which is right here, divided by change in government spending at the bottom, which is right here. Yes or no?
Yes.
Think. Okay? This is the mathematical derivation. This is the diagram to illustrate, number 1, the determination of equilibrium output. Number 2, the changes in equilibrium output due to the change in government spending. Yes? Everybody? Hello?
That makes sense.
Yes.
That makes sense. Very good. That's what I want you to think. Okay? Don't try to memorize the diagram. Okay? Understand the diagram is what I hope that, you're able to do on your own. Okay? So, In the end, what we have is, suppose there's a change in government spending. What you're going to see is that change is in equilibrium output divided by change in G bar is going to be equal to 1 over 1 minus C, 1 minus T. Yeah? Question for you. Is this government spending multiplier given by the expression positive or negative? Is this a positive number or negative number? Hey, guys, you have 50% chance of, huh?
It could be either.
No. C is between 0 and 1. T is between 0 and 1. So the MPC out of a total income is always between 0 and 1. Therefore, the denominator is always positive. So you have a 1 divided by a positive number, give us a positive number. Government spending multiplier is a positive number. What does that mean? Means government spending and the equivalent output, they are moving in the same direction. Government spending and the equivalent output, they are moving in the same direction. Okay? You put money on infrastructure, you expect to see the increase in the economy's output. Agree? Hello? Otherwise, the administration will be in trouble, right? You put money onto the infrastructure and then the economy's output go down. Is that possible? Huh? Yeah? Government spending is a positive number. Government spending is a positive number. A government spending multiplier, I'm sorry. All right. So that's policy instrument number 1. Okay. So now let's deal with policy instrument number 2, right? Which is, suppose we have increase in transfer payment. Okay? Increase in transfer payment. There's an increase in unemployment benefit. So this is exactly what happened in the US after the pandemic hits, right? So regardless, we're talking about the previous or the current administration, they all gave out more unemployment benefits. You extending the period or you raise the amount. So there's an increase in transfer payment. Earlier, we're dealing with increase in government spending directly. Yeah, directly. All right. So transfer payment increased from TR bar to TR bar prime. Okay, which is higher than TR bar. Okay, so as a result, you can write out change in TR bar is equal to TR bar prime minus TR bar. Agree?
Yes.
Say yes. Hello?
Agreed.
Yes.
So change in TR bar here, therefore, is going to be a what? A positive number, right? Positive. Okay. You have an increase in unemployment insurance. Now, connect what I'm talking about here in the classroom to the real world. Okay. All right. So now, once again, we do exactly the same exercise. Okay. I want to find out what happened to the economy's output when there's an increase in transfer payment. So you start with what? A bar equal to C bar plus I bar plus G bar plus C TR bar. Agree? Yeah? And then in this case, we get Y star is equal to A bar divided by 1 minus C, 1 minus T. Okay? So this is where we begin. So go back to the original diagram. Think about this is the original output. This is the original total autonomous spending. Okay? Total autonomous spending, the resulting equivalent output initially, where we start with. Okay? When the transfer payment is equal to TR bar. And now we're going to have a new total autonomous spending because the increase in transfer payment. So notation wise, I'm going to use A bar prime. C bar is the same. I bar is the same. G bar doesn't change. But now be careful. What happened to my transfer payment? What should I do?
BR bar prime.
Yeah, very good. Some of you can be a professor. Yeah? Say yes, please.
Yes.
So therefore, A, my Y prime is going to be equal to A bar prime, 1 minus C, 1 minus T. Agree?
Yes.
Yeah. Okay. So now, I'm going to do the calculation as we exactly what we did before. I'm looking for what? I'm looking for the expression of change in Y star divided by change in transfer payment. Okay. All right. So I want to find out what is this equal to. So that's our task here. We want to analyze the impact of changes in transfer payment on the economy's output. All right. So the way we're going to do is that we start with, suppose I want to find out what is the change in A bar. Okay. So question for you. When you look at the expression of A bar and the A bar prime, what did you see? You see that these are the same. Say yes.
Yes.
This is the same. This is the same. Yes?
Mhm.
Yeah.
Yes.
So at the end, when you want to find out what's the change of A bar prime minus A bar, what did you get? You say, oh, Professor Go is nothing but C times the TR bar prime minus C times TR bar. Say yes, please.
Yes.
Here comes. So therefore, change in A bar is equal to. So,
Change CTR.
but then you have the little c in front of it, right? Yeah?
Okay.
That's the difference. Okay? In government spending changes, you have 1-to-1. In transfer payment, you only have a C times TR bar prime minus TR. Agree?
What does C stands for again, Professor?
I'm asking you. And somebody can help him? What does little c stand for?
NPC out of total disposable income.
This is a Friday. Don't give me heart attack. Friday before the long weekend. NPC out of?
Disposable
Somebody.
income.
Huh?
Disposable income.
Disposable. Yeah. Between 0 and 1, correct? Yeah?
Yes,
And the
sir.
number that we typically put is what? 0.8. Okay. So this is going to be C times changes in TR bar. Say yes?
Yes.
Okay. Change in total autonomous spending is equal to little c times change in TR bar. Before, change in total autonomous spending is exactly equal to change in government spending, change in government spending, change in government spending. Right now, the impact will be smaller on the total autonomous spending. Before it's 1-to-1. Right now it's 1 to little c. 80 cents. Everybody?
Yes.
Good. All right. So now, with this in mind, we can do the derivation of transfer payment multiplier. Okay? So by definition, once again, this is Y prime minus Y star. Okay? Changing equivalent output. Do I have the expression for the new equilibrium output? Say yes, please. Do I have that? Do I have y prime? Guys, say something.
Yes.
Good. So A bar prime. I'm perfectly okay, huh? If you just unmute. Huh? Okay, 1 minus C, 1 minus T. Do I have the expression for the original equilibrium output? Y star?
Yeah. Yes.
Yeah? So when I look at these two expression, do I have a common term?
Yes.
What is that? Seen that
1 minus
before?
C, 1 minus T.
1 over 1 minus C, 1 minus T, correct? And then you have A bar prime minus
Yes.
A bar. Yeah?
Yes.
But then you know that, oh, very good. This is a change in A bar, right?
Yeah, correct.
Agree?
Correct.
Good. But changing A bar is only little c times changing T bar. Right?
Yes.
Say yes?
Yes.
So therefore, my right hand side will become little c, 1 minus c, 1 minus t, changing TR bar. Say yes? You replace change in total autonomous spending with a little c times CTR bar. Say yes?
Yes.
Yes.
So now, yeah, we get the expression of transfer payment multiplier. What is it? What is it? Therefore, C, 1 minus C, 1 minus T. Agree?
Agreed.
So this is our expression for the transfer payment multiplier. Positive or negative?
Positive.
Positive. Lovely. You increase transfer payment. You give up more unemployment insurance to people. Okay? People are not working because of pandemic. People got fired. You give them longer period of higher amount of unemployment insurance every month. The idea here is that at the end, you want to increase the economy's output. The economy is in a recession because of the pandemic. Yeah? Okay. So here, you're going to have C, 1 minus C, 1 minus T, which is a positive. Agree? Hello?
Yes.
All right. So now, in terms of the diagram, I'm going to go back to the same diagram.
So just one thing. So when you wrote the formula, you didn't write in the end changes in TR bar.
When I wrote the expression, say that again,
I'm on the top of the page.
on the top, yeah?
So why didn't you write also changes in TR as well? So after the formula, C over 1 minus C times 1 minus T,
Uh-huh.
and then another times TR.
Why? Why you need that? This is already a ratio, right? Hello?
Mhm.
This is a spending multiplier. And this is the transfer payment multiplier, right?
Yeah.
Yeah. So spend multiplier is going to be a ratio. So you already have, you already take into account change in TR already here. Because at the end, remember, what you end up with is change in equilibrium output. Change in equilibrium output is equal to the transfer payment multiplier times TR bar. and we divide both sides by TR, changing TR bar, we end up with this.
Okay.
Now you got
I
it.
see.
Ah,
Yeah, I see. Thank you.
I divide this to the left hand side. Huh? You got it. Okay, good. Yeah, just ask. Always ask something to clarify whatever confusion you have. Okay. So remember that, this is the diagram we use to analyze what happens when there's a change in government spending, right? Say yes?
Yes.
Yeah. But and then, this is the key feature, right, of changes in government spending. Give us exactly the same amount of change in transfer payment. Agree? Hello?
Yes.
Okay. So now, what I want you to see is, think about this. Suppose I do a transfer payment increase, like what we did. Will increase in transfer payment lead to an increase in total autonomous spending? Say yes.
Yes.
But they are not one-to-one anymore. Say yes.
Yes.
Instead, what you have is that change in total autonomous spending is equal to little c times change in TR bar, right?
Yes.
So when you have a change in transfer payment, there's a little c here. When you have a change in government spending, actually you have a 1 here. So what you're going to see here is that, when you have a change in transfer payment, this will affect the intersect. This will affect intersect. Therefore, the A bar of the aggregate demand. Say yes.
Yes.
So when you have an increase in transfer payment, you will expect to see a parallel shift of equation 1 as well. Agree? Intersect goes up, slope doesn't change. Agree?
Agreed.
However, the increase in total autonomous spending because of the increase in transfer payment will be smaller than the same amount of increase in government spending. Say yes. Hello?
Yes.
So as a result, the parallel shift because of the increase in transfer payment will be smaller. I hate to do this to you guys. It's going to be a parallel shift. But by a smaller amount. When you have an increase in government spending, you go all the way. It's a 1-to-1. When you have an increase in transfer payment, the
0 to
parallel
1.
shift is going to be smaller. Say yes.
Yes.
Okay? Everybody? I don't want to draw a new diagram. I want to put this on the same diagram so that you can hopefully visually see this is the change in government spending. This is going to be the impact of the change in transfer payment, which is going to be smaller. Agree? Hello?
Yeah.
Okay. Another way to illustrate the same point is to think about, Professor Guo, we have the government spending multiplier, which is 1 over 1 minus C, 1 minus T. And then we have the transfer payment multiplier, which is C, 1 over 1 minus C, 1 minus T. All right. So guys, when I look at these two expressions, so this has to do with government spending multiplier. This is the transfer payment multiplier. I want you to look at these two expressions. Do they have the same denominator? Say yes.
They do.
Yes, I do.
Yeah.
One has the numerator 1. The other one has numerator C. This is the marginal propensity to consume out of disposable income between 0 and 1. Therefore, which one has a higher numerator?
Government spending.
Government spending.
Government spending multiplier, correct?
Yes.
So therefore, when they have the same denominator, this one has a larger numerator. The result is that the government spending multiplier will be larger than the transfer payment multiplier. Agree?
Yes.
So therefore, question for you. Suppose you are the economic advisor to the president, and the president asks you the following question. He asks, suppose I increase government spending by $100 billion versus increasing transfer payment by $100 billion. Okay. I have two options. And obviously, both changes will raise the economy's output, correct?
Yes.
Which one will be raising the economy's output by a larger amount?
Government spending.
Hey, government spending. Very good. Government spending is more powerful in terms of affecting the economy's output compared to the same amount of change in the transfer payment. Say yes?
Yes.
Make sense? Hello? Think, huh?
Clear.
You have the infrastructure, you have unemployment insurance. And this model is telling you which one is more effective in terms of the affecting the economy's total output or so. All right. The final one is, suppose we consider a tax cut. Okay. A tax cut. From T to T prime, which is lower than T. All right. So change in tax rate is equal to T prime minus T, which is smaller than 0. Agree? Hello?
Yes.
So, once again, you start with A bar equal to C bar plus I bar plus G bar plus C T bar. And then in this case, you get the equilibrium output equal to A bar divided by 1 minus C, 1 minus T. Agree? So yes?
Yes.
So in this case, my aggregate demand is equal to A bar plus C, 1 minus T times Y. Okay. All right. So now I need to use another page to draw the diagram. So to make sure that, we are all on the same page for this. So I have aggregate demand, I have Y, and I have the first equation. Okay. I have the first equation. Let's start with A bar, and then AD is equal to A bar plus C 1 minus T 1. That's my equation 1. And I have the 45-degree line, AD equal to Y. Intersection is my Y star. Okay? So this is just repeating what we have already done many times by now. All right? So this is the initial situation. Okay? Initial situation. All right. Now, the government comes in saying that we want to do a tax cut. Okay. This is the Republicans' favorite fiscal policy instrument. When the economy is doing well, they do the tax cut. When the economy is not doing well, they also do the tax cut. Okay. All right. So now, question for you. When you have a lower tax rate, okay, when you do a tax cut, does A bar change? Does A bar change?
No.
No. A bar is the same, right? Say yes.
Yes.
A bar doesn't change, right? There's no change in C bar, no change in I bar. Yeah? Agree? Everybody?
Yes.
And then you say, oh, very good, but now my Y prime, because the A bar doesn't change, so my numerator remains to be A bar, correct? Yeah?
Yes.
And then, but now my denominator becomes 1 minus A T prime.
Minus 1.
Say yes. Hello?
Yes.
And then, at the same time, my new aggregate demand schedule is A bar plus C 1 minus T prime Y. Agree?
Yes.
Yeah? Okay. So here, before we continue, I want you to think about, in terms of the most basic intuition you guys should have. What's the logic? What's the logic behind, tax cut? When we cut down taxes, what happened to your disposable income?
Goes up.
Increases.
Your after tax pay, right? Your paycheck now becomes higher, correct? Hello?
Yes. Yes.
All right. So when you have a higher disposable income, what do? Oh, I go out to have more beer, right? What does that mean? You increase your
Spending.
consumption in particular, yeah. Right? When
Yes.
consumption goes up, hey, what happened to the economy's aggregate demand?
Increases.
Goes up.
When demand goes up, equipment output what?
Goes up. Okay.
So what you see here is that a decrease in taxes will raise the economy's output, correct?
Yes.
So what do you expect to see, therefore, is in the end, when I derive the tax rate multiplier, change in Y star divided by change in little t, positive or negative?
Negative.
Tax rate and the equivalent output. Tax rate and the equivalent output are going to be moving in the opposite direction. Agree? Hello?
Yes.
Yes.
Think. Economics is, pretty straightforward. When you think this through, it has to be consistent with our daily life. Otherwise, what the hell we're doing here, right? So now, I want to ask you, therefore, when there's a tax cut, T goes down, does that affect the intersect of the aggregate demand equation? Say no.
No.
Good. And that affects the what?
Slope.
The slope, right? When T goes down, what happened to the slope of the aggregate demand schedule? The slope is equal to C 1 minus T, right? Which is the marginal propensity to consume out of total income. So when T goes down, when there's a lower tax rate, what happened to the slope of my aggregate demand schedule?
Does it increase?
There's a lower T, there's a negative number, so the entire slope will go up. Say yes. Hello?
Yes.
Good. So now you say, oh, therefore, in this diagram, when there's a lower tax rate, the intersect of my aggregate demand equation doesn't change, correct?
No, it doesn't.
The slope becomes higher, correct?
Yes.
So you are not going to see parallel shift anymore. Instead, you're going to see a what? A rotation starting from the same intersect here of the aggregate demand equation. Say yes.
Yes.
T goes down, slope becomes higher. So therefore, the new aggregate demand schedule will become what? Steeper. Say yes. It's going to be my AD prime, which is equal to same intersect plus C 1 minus T prime. Y.
Right.
Agree?
Yes.
Good. And then you say, oh, but we go intersection, new intersection, give me E prime. So therefore, I'm going to have my Y prime. T goes down, but Y star goes what? Up. Agree? Hello?
Yes.
All right. Then the final thing we need to do is to derive, what's the tax multiplier? Y prime minus Y star. Then you say, oh, Professor, my Y prime is A bar, 1 minus C, 1 minus T prime. Agree? Hello? Yeah?
Yes.
And then what is my Y star? Y star is A bar, 1 minus C, 1 minus T. So when I look at these two expressions on the right-hand side for the new and then old equilibrium output, tell me, what's the common term? Do they have the same numerator? So
Yeah.
you have the A bar times 1 over 1 minus C, 1 minus T prime, minus 1 over 1 minus C, 1 minus T. Agree? Hello?
Yes.
Please tell me that, oh, boy, today is the Friday before the long weekend and you only have 2 minutes left. You don't want to continue anymore. Is that what you have in mind? Say yes.
No.
No? You want me to continue? Because I
Yes.
don't know how to continue either. All right, guys, you do not need to. All right, we do not want to continue anymore. All right, because once we continue, you're going to get ugly, complicated, expression that I don't want you to, memorize, right? Or, even see it. All I want you to know is that in principle, what you get is that you should be able to get an expression of change in Y star divided by change in D. Say yes. Hello?
Yes.
If I continue, right? In the end, I'm going to get something like this. I'm not going to give you the expression. All right? Don't worry about it. It's in the textbook, but you don't worry about it because I'm not covering it in the lecture. But the key here I want you to be aware is the sign of the government of the tax rate multiplier is going to be what? Negative. Say yes.
Yes.
This is the key. Okay. This is the key. So that goes back to our original discussion here. When we talk about fiscal policy, change in government spending multiplier positive. Change in transfer payment multiplier positive. Change in the tax rate, we're going to have the tax multiplier. I'm not going to give you the expression. Don't worry about it. And then this is negative. Everybody?
Yes,
Make
sir.
sense? Hello?
Makes sense.
So this is the end of chapter 10. Any question?
When do we get to chapter 10?
Say that again?